So in this chapter, we're talking about compounds that contain oxygen single bonded to carbon. So we talked about alcohols and phenols, and another group that falls in that category are ethers. So ethers are organic compounds in which we have an oxygen atom bonded to two carbon atoms by single bonds. So the general formula is ROR. These R groups are alkyl groups. They could be methyl, ethyl, hexyl, anything you want. It's kind of a generic R. So the functional group in these is COC. And of course these carbons are going to be bonded to other things. But this is the functional group we're looking for. So here are some examples of ethers. Here we've got the oxygen between two carbons. Oxygen between this carbon and that carbon. Oxygen between two carbons. That's the functional group. That's what identifies it as an ether. We talked about how we can view alcohols as being a derivative of water. We can also view ethers as being a derivative of water. So here's water. It's got two hydrogens single bonded to oxygen. In the alcohol, we swapped out one of these hydrogens for carbon. Could be, methyl, and then we have methanol. Here, we're going to change both of those hydrogens for carbon groups. And so we have an ether. The smaller ethers have common names, and those are used frequently for these smaller ethers. So how do you name it with the common names? You look at the two hydrocarbon groups that are attached to the oxygen, and then you add the word ether after that. So we'll look at this example. Here's the oxygen, and we're looking at what are the R groups? What are the groups that are attached? Well, this is a methyl group, and this is an ethyl group. And then we put those names in alphabetical order. So this is ethyl, methyl, ether. This one has an ethyl group and a butyl group. So this is butyl ethyl ether. It starts to get kind of funny after a while. On this one, both of these groups are the same. There's a methyl and here's a methyl. So instead of saying methyl-methyl ether, we call it dimethyl ether. And you can have diethyl ether and dipropyl ether. Those are common names, just for the small ones. IUPAC names are what we use for the larger ones. So here we're going to look at the oxygen. Like on this one, we're going to look at the oxygen and which groups are attached to it. And we're going to look for the longest carbon chain. And we're going to use that as the base name. So it's kind of following a pattern. And then we're going to take the other piece and we're going to change its ill ending, like this over here. This is ethyl, isn't it? It's ethyl. We're going to change it to oxy. So ethyl becomes ethoxy. So we're basically looking at two sections here. So this is the ethoxy part. And let's switch colors. And this is butane. So there's 1, 2, 3, 4 carbons. There's a 4-carbon chain there. The 2 comes about because the ethoxy group is attached to carbon number 2 on that chain. You see that? So we look at the compound and we're going to put the oxygen with the smaller side and name it as a substituent to the larger portion. Here we've got a 4-carbon chain, which is butane. Over here we've got a 2-carbon alkyl group, which is ethyl. Because it has this oxygen here, we call it ethoxy. It's ethoxy butane, and it's attached on the 2nd carbon. Let's look at this one. So here we have ethyl, and over here we have benzene. Benzene's bigger than ethyl. So the base name is benzene, and this guy over here is ethoxy. And it becomes ethoxybenzene. We don't need a number because benzene is a ring. And if ethoxy is all that's attached to it, it doesn't matter where it's attached. Here's another one. Here we've got, this is cyclohexane, and it's attached to an oxygen over here and an oxygen over here, and both of those have methyl groups. So the cyclohexane is the largest group. Attached to the cyclohexane, we have a methoxy group here and a methoxy group here. And so we're going to number them so they would have the lowest possible numbers. 1, 2, 3. So we've got 1, 3 dimethoxy cyclohexane. Yes?
Can you show where the 2 is on the methoxybutane?
Yeah, where's the 2 on that first one? Do you see I numbered this chain here?
Yeah.
1, 2, 3, 4. This is where the 2 comes from. Because this group is connected to that carbon. It's one of those things, you kind of have to look at it for a while till you can see it. You know, if you've never played football and you watch some guys playing football, it looks like a bunch of people running around hitting each other, and it makes no sense. For people who've played a lot of football and studied it, they can see, oh, the safety's doing that, and the tight end did this, and they, oh, look at that, and they can see it because they've studied it and looked at it. So it's kind of the same way with this. This is like, you know, play diagrams or something in baseball or basketball or football or whatever. Any other questions? Again, we've got a common name for the simplest aromatic ether. This has this methoxy group attached to a benzene ring. And this has the common name anisole. And we did see this in one of the previous slides about the phenols. But so a derivative of this would be named as a substituted anisole. So like if you had chlorine over here, it might be 2-chloroanisole. Practice exercises. Name the following ethers using IUPAC nomenclature, not common names. So what do? Well, IUPAC nomenclature says that we're going to look at these groups here and find the biggest one. Well, those are kind of the same size, aren't they? Well, we'll just pick, let's say, okay, well, this is the group that we're attaching to. I'm sorry, that's the oxy group, and here's the other one. So this is going to be the parent name, 1, 2, 3, Mom Eats Pickled. So this is propane. And this guy over here would be propoxy. Am I saying that right? Some of these get kind of funny. So it'll be propoxy propane. And then we have to say where it's attached. So on this guy, and we want it to be on the lowest number, so we're going to number from here. So this is 1, 2, 3. So this group is attached to the 1 carbon. So this is 1 propoxy propane. Just like with human names, some names sound cool and some names sound weird. That's a weird one. Any questions about that one?
Do you have to put the 1 because it's kind of the same both ways?
Well, you have to put the 1 because it could also be attached on the second carbon. If it was attached here, that would be 2 propoxy propane, and that would be different. You couldn't have 3 propoxy propane, though, because that would be just an incorrectly numbered 1. Good question. Any other questions? Let's look at this next one. Well, this is our big group over here, isn't it? That's got 1, 2, 3, 4 carbons, and this guy over here only has 1. So what's our chain over here? What's the longest chain we have? Propane, right? there's 3 carbons. 1, 2, 3. So this is also going to be a propane. It's got this guy on it, which is methoxy, and it's got this guy on it, which is methyl. So which one do you think should go first? Well, we use the alphabet to decide, right? So the first 4 letters are the same in both of them, but when we get to the 5th letter, O comes before Y. So we're going to put methoxy first and then methyl. So the methoxy group is on carbon number 1. So that's 1 methoxy. And the methyl group is on carbon 2, 2 methyl propane. Just double checking here. Yeah. Isn't that fun? Any questions? Yeah, so big skills in organic chemistry include counting and alphabetizing. Here's another one. This guy's kind of funny looking. Well, here's our oxygens. Got 2 of them here. This would be a methyl group, right? Just a single carbon. And this guy is what? Cyclohexane. So cyclohexane is the biggest portion. So the base name is going to be cyclohexane. So we're going to name this group, that's methoxy. Not methyl, methoxy, because of the oxygen. And this is another one. So we have 2 methoxy groups. That's dimethoxy. Dimethoxy cyclohexane. IUPAC nomenclature is using the numbers, not the ortho, meta, para. So we would number starting with one of them and go to the other one as fast as we can. 1, 2, 3. This will be 1, 3. Dimethoxy cyclohexane. Pardon me?
How would you ask?
Okay, so if it was a common name, then we could use ortho, meta, para. And so what would this one be? Meta. The way I remember that is this is your principal, this is ortho, meta, and para. So this is meta. Any other questions about that one? Let's name this guy dimethyl ether. Wait a minute, that's a name. But that's not the IUPAC name. That's the common name. Might be helpful to draw this. So dimethyl ether. The common name says, okay, there's the ether. What's attached to it? Dimethyl. Well, 2 methyls. So we've got methyl here and we've got methyl there. Nice little symmetrical molecule. IUPAC nomenclature says, pick the largest one and put the oxygen with the smaller one. Well, here they're the same size, so you can pick either side you want. The base name then will be methane. And what's attached to it is methoxy. And those should go together. Left too much space. So the IUPAC name is methoxymethane. Dimethyl ether has a much nicer ring to it. Any questions? Almost out of time. You have maybe heard of MTBE, I don't know about you, but when I'm standing at the gas pump pumping gas, you know, sometimes it's boring, and so you read all the stuff on the pump, right? And it says MTBE. That is methyl tertiary butyl ether. Here's its structure. That's in your gasoline. It's put in there for a couple of different reasons. It raises octane levels, and it helps the gas burn more cleanly. They're backing off on the MTBE a little because they're finding that it's been leaking into the groundwater. And it hasn't been a big problem yet, but they're saying, okay, maybe we need to back off a little bit and not put quite so much in the gas. But there is an ether that is in something you use a lot. Another use for ether, ethers are useful for general anesthetics. Diethyl ether was the first general anesthetic. I actually heard there's a podcast, I think it's called Stuff You Missed in History Class, and they talked about diethyl ether. Before diethyl ether, there was no anesthetic for surgery or dental work or anything, you know, and they're going to take your appendix out and they'd maybe get you a bit drunk, and that's about all they could do for you, and it hurt like hell, I'm sure. So discovering an anesthetic that would knock you out without killing you was a tremendous thing. It was awesome. So diethyl ether was the first general anesthetic, and it was used for quite a while. The problem was it's also very, very flammable. And you don't really want explosions going on in your operating room. So they worked on it, and now what they use mostly are polyhalogenated ethers. By putting halogen atoms on the ethers, it reduces their flammability significantly. So ethers are used in the operating room. We'll stop there.